Welcome to aminacademy.com. In Laplace transform, let us discuss about some properties of inverse Laplace transform. First one, linearity property. If C1 and C2 are any constants, while f1s and f2s are the Laplace transform of f of 1t and f2 of t respectively, then inverse Laplace transform of C1 f1s plus C2 f2 of s is equal C1 inverse Laplace transform of f of t plus C2 into inverse Laplace transform of f of 2s. Here, look at here. First, the C1 and C2 are constants. Here, inverse Laplace transform of C1 f1s plus C2 f2s. Then here the C1 and C2 is splitted for that is inverse Laplace transform of two functions, that is sum, is separated, that is C1 into inverse Laplace transform of f of 1t plus C2 inverse Laplace transform of f of 2s. Here you can understand this concept using some example. Look here, for example, inverse Laplace transform of here 5 s minus 2 plus 3s over s square plus 16 minus 5 over s square plus 4. Now this inverse Laplace transform is splitted for each function, then you can find, which is equal 5 times inverse Laplace transform of 5 over s minus 2 plus 3 inverse Laplace transform of s over s square plus 16 minus 5 inverse Laplace transform of 1 over s square. Here 5 is taken out, here 1 comes, s square plus 4. Now we are applying separately the inverse Laplace transform of each function, which gives 5 inverse Laplace transform of 1 over s minus 2 is e power 2t plus 3 into inverse Laplace transform of s over s square plus 16 is equal cos 4t, because 16 is split as 4 square, and minus 5 inverse Laplace transform of 1 over s square plus 1 over s square plus 4, which is equal 5 over 2. Then s square plus 4 is, that is 4 is taken as 2 square. Then you can apply the formula, that is sine 2t. Now we will discuss second one, first translation or shifting property. Here, if inverse Laplace transform of f of s is equal f of t then you can see which is equal inverse Laplace transform of f of s minus a is equal e power at into f of t. Here we'll do an example, you can understand this. Find inverse Laplace transform of 1 over s square plus 9 is equal, we'll put here 4, half of sine 2t, then from that we are using this principle, that is inverse Laplace transform of f of s minus a equal to e power at into f of t. So we can use inverse Laplace transform of 1 over s squared minus 2s plus 5 s squared plus, that is minus 2s plus 5, which is equal inverse Laplace transform of, here that means we are using finding the inverse Laplace transform of this function. We are keeping like here completing the square, we have 1 over s minus 1 the square plus 4. That means if you expand s minus 1 whole square is s squared minus 2s plus 1 and 4 is there, so 1 plus 4 is 5, that is here. Then which is equal half of e power t sine 2t. That means we are using this here. Now next one, second shifting property. Here if inverse Laplace transform of f of s, which is equal f of t, then by using second translation property we have inverse Laplace transform of e power minus at and f of s is equal to f of s minus a if t is greater than a, and the second one it is 0 equal 0 when t is lesser than a. We'll do an example. For this you can do example, look at here, inverse Laplace transform of e power minus t into pi by 3 over not t, it's pi s is equal and s square plus 1, you can use it this as sine of t minus here t is at t pi by 3, so t of minus pi by 3, then it is if t is greater than pi by 3 and 0 if t is lesser than pi by 3. Now next one, change of scale property. For change of scale property, the theorem is if inverse Laplace transform of f of s is equal to f of t, then we can define, then inverse Laplace transform of f of k into s, k is a constant, which is equal 1 over k f of t over k. Now, for example, you can use it. Inverse Laplace transform of s over f square plus 16, we can write as it is equal to cos 4t by using formula. Then we have inverse Laplace transform of 2s over 2s square, that means here k is 2 plus 16, which is equal 1 over k, that is 1 over 2 and cos of 4t over 2, which is equal half cos 2t. Here we went through, that is first one, linearity property, first translation R-shifting property, second translation R-shifting property, then change of scale property. We have done. Please subscribe our YouTube channel.